Okay, in this video we'll be talking about several things relating to the F256 Jr. This also applies to the F256K, and then we'll talk a bit later about what this means for the F256K2, which is the upcoming new machine that Stephanie Allaire will be releasing, I believe in the next month or two. This is being recorded, I guess we're in the second or third week of September, which is 1 week after VCF Midwest, which I attended. I'm tying together a few things that I've been working on. One of them happens to be the Dream chip. If you've been following my channel at all, or been following on Discord, you'll see that I talk quite a bit about this Dream.fr, right, French company, SAM 2695 IC, which is this tiny thing right here on this board. I'm also going to talk about the integration, or what I consider to be kind of a final, I don't know, integrated design of the work I had done previously onto this little board and snap-on attachment, which you can add to your own Junior or K if you have one. I'll give you an idea of how to build it. I'll give you links and things to order your own parts, etc. If you reach out to me on Discord, maybe I'll even build one for you. But I want to start by saying that I'm covering 3 or 4 things in this video. I'll try and speak quickly so it's not 40 minutes. One is MIDI, and specifically general MIDI integration into the Dream chip. One is the F256 Jr. and a piece of software that I wrote that runs on a Junior or a K, and eventually it'll run on the K2. One is this hardware, which is based on, well, it's based on this board, this prototype, which I brought to VCF Midwest. I had hoped to bring this to Midwest, packaged up nicely and, you know, everything routed through the normal outputs, but I just didn't get the hardware done in time, unfortunately. It took me an extra week to get there, and because I was working so much on the software, which I'll get to in just a moment. But this is the prototype design. I dragged this thing along. I dragged this along with it to plug a bunch of headphones into. I bought a bunch of low-cost headphones, which as it turned out had like 4-foot cords, and the few people I showed it to, there's about a dozen people in total, were pulling this thing. It was kind of a mess, but I didn't get a chance to put it on the table like I'd hoped to. But here I am today, so hopefully more people will see this. I want to give a acknowledgement to Michael St. Pierre, who put this together, designed this. This is based on the MIDI.org reference design, the 1.0 specification of what a hardware MIDI and adapter might look like from a circuit perspective. It's easier to point to it here, but essentially the right half of this board, the right portion of the board, is the MIDI in interface. The left portion is the Dream kind of MIDI out, you could consider it, because the out gets routed right to this. And in between, this is essentially the Junior sits right here in a box, an imaginary box on the bottom. Michael put this board together, and I bought a bunch of them on one of those PCB manufacturing sites, and that's what is on this board here. So I won't dwell on the hardware anymore, except it probably costs around, I don't know, $8 to make this thing. And it probably cost around $15 to buy this integrated component and make the rest of it. And the rest of it is just some, you know, soldering and assembly, what I'll call relatively minor DIY skills. There are 3 places on this board I'll need to solder to get this thing up and running, and I had to. One of them is soldering a header connector into the feather socket. One of them, which is optional, is wiring it into 5 volt on the Junior board if you want it highly integrated. The third, also optional, is wiring it into the auxiliary in that goes through the Wolfson codec. C-O-D-E-C, codec, not Kodak, codec, which brings the stereo into the board, and then it gets mixed through the codec to the normal outputs or the headphone jack, which is nicer. But you really only need to put on, the minimum is this one small single line header where you can get access to MIDI in and MIDI out, or rather serial data in and out. So without any further delay, I'm going to jump onto the software, bring it up. We'll talk about how these two things work together, and I think you'll be suitably impressed. I'm recording this in kind of on a capture device, and hopefully the audio will work out, but we'll know when I press the first key. So to start with, I'm going to load, well, that's not it. It's called retro scope.data, putting it to 30, that's 30,000. Which, if you know the Junior memory map, that's well above the first 64K memory. So this is, this is up on, I think, the top quarter of memory, which is 512 K memory in this. It's got 512 RAM, 512 flash, that's done already, 512 flash, and then optionally a cartridge port with more memory. It could be either read-only or RAM. Now I'm going to load the smaller piece of this, which is the code itself. Can't really see what I'm typing here, but hopefully that'll do it. It's going to go into 2000. Okay. And as soon as I get my cursor back, oh, there it's done. Okay, now I'm going to call the old Apple command to 4030. Now, obviously, this will be bundled up into an executable, probably a PGZ file eventually. So here we are. A couple things to point out. The first thing is the actual full name of it is the General MIDI Retroscope, which means it's made for General MIDI. It's a scope where you can really see and gather information on what you're playing on a MIDI connected keyboard. And there's a retro element to it, which we'll get to. The screen's set into a couple different sections. On the top right, you'll see lives 3, bonus 0. What does that mean? Well, we'll get to it. The main window at the top, which is more like Defender, if you want to talk about retro gaming or retro in general. The top is basically where you see a heads-up display on everything that's happening, which is, would see the whole universe in Defender, the game. Here you'll see bytes spreading across the screen where the white cursor is currently located, and that represents 256 bytes of information, 64 lines times 4. On the right side where it says no data, there's a box where you'll see MIDI notes come up, and then you've got text. The rest of it is essentially text, or at least the top 2/3 is text. It talks about some of the features, how it's integrated with this particular controller, and this is the MiniLAB 3 edition. And then it has some glyphs on the left in color, and they represent things like note on, note off, control change, program change if you want to change the voice, depending upon your keyboard. You get to that in different ways, pitch bend, etc. So we'll go through that. And then finally, at the bottom, you'll see the selected patch, which in this case is acoustic grand piano, patch number 1, program 1. And it's in these are the official sound sets that MIDI.org specified, and I think the 1991 version of General MIDI, which is the 1.0 spec, I believe. If I'm incorrect, I'll correct it in the notes. But the way this works is, I'm going to put my headphones on so I can hear what you're hearing. I'll press a key, I'll press C in this case, and you hear a piano. I'll let go of the C. And you'll see at the top, 6 characters were typed there. There's the note on command, there's the number 0, there's the, what is that, W, capital W it looks like. That represents the note on of MIDI number 0, which if you know ASCII is what, 48, I believe, somewhere in the middle of the range. And then W is the velocity. On the right side, at the rightmost by the cursor, is the release velocity, otherwise known as 0, I believe. So that's probably that English pound sign. So I can play chords, whatever I want. And you'll notice 2 things, that the display above is continuously updated as I play. And the part on the right, the box, is kind of an interpretation of the key I'm pressing, in this case, note on, note off. Now what I'll do is, I'll change the sound from piano to something else. We'll talk in a minute about how it changes. But as I rotate this knob, which is number 5 on this this MiniLAB, you'll see the patch go up. I'm bright acoustic piano, etc. Another nice thing about this keyboard is that there are these sliders here. Well, first of all, I have volume per channel. Channel 1 is volume for this. These drum pads are bound to, or these pads are bound to drum sounds. And there's actually 2 banks of them, but these are just the defaults. So that's pretty handy. And again, these just come across as MIDI notes. So as I slam, I should say, on the on pad number 1, you'll see the bass drum note. In the same way that I get a MIDI note. It's just that it happens to come across a different MIDI channel. It has its own volume, which is nice. And these pads actually have aftertouch. So if I push down and hold and press, you can see that dark green. Those are aftertouch bytes. So that's all well and good. I should add that on this little teeny controller, there's also modulation on this left ribbon. So you'll see, sorry, modulation is the right ribbon. You hear that vibrato, so to speak. Okay, there's this pitch bend wheel. And by the way, you'll notice in the display on the right in the box, I hold down the key, let go of the key, right? Note on, note off. As I press up on the ribbon, you see the value changing, going up and down. So this is continuously updated based on that CC happening. Again, nothing magic about this. These are just defaults of this keyboard and the fact that it talks general MIDI and this chip is able to receive general MIDI. All I'm doing as an application is routing bytes in to byte out. We'll talk about that another time as well. Quickly moving on to pitch bend. I do something a little special here. Not a big deal, but if I press a key, let me pick a different patch actually. So you can see that line, when I press that, you can see it, right? If I go up, down, up, down, up, down on the pitch wheel, you'll notice that in the box, that's varying pitch. So that's another kind of thing I threw in there. And then there are other controls which I mapped certain ways. I didn't mention it, but number 2 is drum volume, where number 1 was the synth volume. These sliders add reverb, and this is channel reverb built into general MIDI again. Hear the difference. Chorus. Let me put chorus on an organ sound. That'll be more convincing. Let's see. Get down to, where are they? Right after here, I believe. Let's see. Percussion. Now I'm an organ. Okay. I watch my level there. So this has a bit of phasing in the tone, as you can hear this with headphones. But if I turn modulation up now, it's vibrato. Now if I turn up the chorus, it's more of a lush Leslie type sound. You can also add reverb and chorus if you like. Anyway, those are some of the features. What else can I do here? I mean, I could pick a bunch of different sounds. Now, I should mention in this tiny keyboard, which is extremely small, it's got 2 octaves of these kind of mini keys, hence the name MiniLAB. You can change the octave. So by pressing, and this Dream chip having, wavetable type samples, they're sampled at a certain range for a given instrument. So some of the sounds, which will be interesting in a moment, some of the sounds sound really cool or different at different octaves where they're not really intended on being recorded or played. That does not sound like an organ. At the upper range, there's where it sounds correct. Anyway, which one is this? Is it a percussive organ? Yeah, it is. So that's just a quick run through of the basics of this thing. There's 2 other features to show you about. One is one is that you have built-in portamento. You can turn it on with switch 7, and in general MIDI and in MIDI in general, this is a portamento is a standard CC. But in MIDI in general, switches, which are binary, either off or on, are range-wise. Values below 63, you'll see as I get this up to 40, which is 64. This knob, number 8, is the portamento time. And as I turn this back down to 39, I guess, or 30F, I should say. There you go, and up to 40. Now it's in volt. So you have full range of ridiculous, speed, or rate, I should say. It's very slow. In fact, I can go all the way down to the bottom of this thing and then press the lowest MIDI key, takes a while to get there. So that's something else. And the last thing I want to show you is there's something called sustinato, I believe, which is an Italian word for sustain. And let me get a more reasonable. If I wanted to hold a chord like that, I could turn 6 all the way up to turn that switch on. Now it's playing. I could turn the volume down a little bit. I could pick a different channel on MIDI, like say channel number 3, by holding down shift and pressing the third. Now I'm going to talking channel 3 while channel 1's playing the drone. I could change the program, I believe, through here. Maybe I can't. Let me see. No, I can't. But I can do. So it's interesting. It's full featured. You can do a lot with it. So that's basically what I wanted to show you with regard to the software. Bottom right of the screen, you see kind of a QR code. You can put your phone up to. It'll take you to Amazon hosted site for some documentation, I believe, which takes you over to the marketplace where you can download either this code or other things like any of the newsletters I've written on the topic. Now, how far through are we? I don't know. Maybe I'm wasted 10 or 15 minutes talking about this. 16 minutes in, I'm going to show you yet another feature, which I did specifically for VCF Midwest. And I use this tool to model sound effects with the intention being, guess what? It's great having a dream chip in your computer. And of course, PCs have been doing it for years, as recent as say 2018, 17, 16 maybe. There were these add-ons where you can take a dream chip and put it inside of your Sound Blaster, right? With that add-on connector. There was a header that was included on the Sound Blaster for this very use. The X16, the Commander X16, has a dream chip on the way. I believe it's going to be released this month. I was talking to Kevin Williams at VCF Midwest, and he's had some problems with the board that he originally hoped would come out, I think along the lines of his serial card back in February, March timeframe. Maybe it was March or April. But he's ready to release it now, so he's got that all addressed. He's got 50 of them made, I believe. Here they are here. But the point is not just for music, but for sound effects and for things like games. It's incredibly easy to write code to use the benefit and power of general MIDI within a game, not just for a soundtrack, but also for sound effects. Now, I demonstrated when I played, let me go back to channel 1. When I played before, I demonstrated, that's a good one, reverb, chorus, and the fact that I can play a whole bunch of notes at a time. And you'll notice on my device here, hopefully that's in the view, you can see a little red light blinking. That blinks every time it receives a byte. So when I press this and release it, I'll just press it and hold it. 3 bytes were received, 3 bytes were received on release. With just 6 pokes to memory, I've played a note. And I don't have to worry about vibrato, I don't have to worry about reverb on or off. As a game programmer, this becomes extremely useful. Now, speaking of games, I'm going to show you a different mode of this, which I made, of course, for the VCF Midwest. This is kind of the punchline here. I'm going to replace the picker below with these Space Invader characters. They do not currently move, so I don't get anybody's hopes up. But you got this little ship on the bottom, which I created. And for the Foenix people, this is remapped characters at 640 horizontal resolution, so it's twice the resolution of normal sprites and whatnot. And the point is you can listen to the sound effects. And these were modeled by choosing general MIDI instruments, which I found a certain octave. In some cases, like the smaller Invader, I believe I had portamento on. Not that guy, this one. So you hear that? Wink? That upward bend is portamento on each shot. Anyway, there's a couple different sound effects in here. This one is not intended, but that's what you get. When you hit this barrier up here, you can't shoot that, so get a little thud. And then the real fun comes in where you turn this knob. It's kind of the hidden feature. Oh, also, I should mention that in this mode you have scoring in the upper left-hand corner of the screen. And this is where, of course, the lives and bonus come in, though I haven't written that code yet. So the intention is to release this. I'm going to do some work on you know, the interface. The Space Invaders characters will be moving. You could shoot them, and there's one added kind of treat, which is if I turn the sustinato, I don't know how to say it, to the right. Now, when you press a key on the keyboard, you get falling objects. And these are sprites, and I had a lot of help with this part of it. In fact, somebody created an engine for me based on the original intent, which was to have falling notes. As you play it on the keyboard, say I press C, E, G, that it would drop the letter C, E, G, but no, that was no fun. The person that did it for me came up with all these great symbols from Ms. Pac-Man and from the Pac-Man series, if you recognize it. So with that, what I'm going to do is I'm going to turn on the arpeggiator, which I'm not going to spend too much time talking about, but I can do this, and I think that turns it on. Yes. Now I'm going to pick, I don't know, this chord, a C sharp, sus. I'm going to press hold. I'm going to turn the frequency up a bit. Let's see. I think if I hold, that's not it. Is it? Yeah, that's something right here. Okay, let me do it again. Okay, now I'm going to, these will remap to arpeggiator features, and I want to change the rate. So you get the idea now. We'll see you next time.